You can think of the facade pattern as a wrapper. So you can see it as a wrapper for many subsystems in an application, and you use it to reduce complexity. So for example, we can have a computer. A computer has several subsystems. So we have a central processor system or subsystem. We have a memory subsystem and a disk subsystems. And all these subsystems have different functions. For example, the processor can do an operation. The memory, you can load things into memory or unload. Your disk can read or write. Oh, got a typo here. So you can imagine with a lot of different subsystems, the program become very complicated to understand, because you have all these subsystems and you don't really know where to start and which subsystem does what and so on. So you can use a facade pattern, which is like a wrapper for all of this. So in this case, we would call it ComputerFacade, where we have an initialize function, which initializes all the subsystem or components. So once we create an object, it automatically initializes all of the subcomponents or the subsystems. And we can interact then using the facade with all the components. So the end user only has to know how to use the methods in the facade, and it doesn't really have to know about all of the subsystems methods. So for example, we could have a method start in which the processor does something, and perhaps it loads something from the disk. And maybe also it does something with the memory. And you can have different functions there. However, the end user doesn't need to know about any of the subsystems. It just needs to know about the facade and the methods. So in this case, it can only do start. So we can create a new computer. And we can say computer.start. And if we run it, you'll see I may use an object that doesn't exist. Okay, if we run it, you see it does the steps. It's using those subsystems. However, the programmer only needs to know about the facade, so we can say start, and that method is using all of the subsystem components. Now, of course, this will grow in time. So perhaps there's a stop methods or other kind of things you want the computer to do. So stopping perhaps does something with the memory. So the end user only needs to know about the methods in the facade, and it doesn't need to know about the subsystem. Now, of course, in this example, we only have 3 methods for every component, but you can imagine for complex systems, every subsystem may have hundreds of functions or hundreds of methods. And if you only have subsystems with methods, it becomes very complicated, because you don't know, if you're not an expert on the topic, you don't know which components you need exactly, and it's very hard to maintain. However, if you would have a facade, you just have the methods, and those methods interact with the subsystems. So you can see it as a wrapper around the subsystems.